All right, guys, section 3.1, problem number 13. They're asking you to refer to this graph down here in figure 13 and determine f prime of a for 4 different values of a here on this graph. So this is a really good problem to help us remember one key idea right here, and I think this was in the notes right here, that when we're trying to figure out what a derivative actually is, that basically tells you 2 different things here, guys. One of them is going to be your instantaneous rate of change, and the other one is going to be the slope of a tangent. And in fact, there should be an arrow going here between those. These 3 concepts are all one and the same. So in 13, they're asking you for the value of your derivative, f prime of a, evaluated at a specific point. And because we're dealing with a graph, we're really going to focus on this idea right here. All we're going to do to answer these 4 questions is figure out the slope of the tangent line at each of these 4 points here, 1, 2, 4, and 7. So let me go to where x is equal to 1 on this graph, which would be this point right here, and you'll notice that we're dealing with a linear function here that in fact not just is linear but is horizontal. So if I were going to try to draw a tangent line right there, it would look like the line itself, and the slope of that horizontal tangent is equal to 0. Therefore, the value of f prime of 1 is 0 because that's the slope of the tangent line to this curve drawn at x equals 1. Now, to do f prime of 2, I would do the exact same thing again, but this should go pretty quick and easy because really all we're doing is now taking a look at that point right there, and you'll notice it's the exact same thing happening right there. We still have a horizontal or a constant function right there, which means our tangent line is going to be horizontal as well, and yet again then, the slope of that tangent is 0, which means f prime of 2 is going to be 0 as well. But now I think things start to get a little bit more interesting. The next one we're looking at is f prime of 4, so now we're focusing on that point right there. And now you can see that our function is no longer constant, but it's now increasing. However, good for us, it's still a linear function there. So the tangent line drawn to a linear function is going to look exactly like the line itself right there, guys. So to figure out the slope of that tangent, we're really just looking at the linear function that goes from right here, the point 3, 1, up here to the point 5, 2. And on that speck right there, our slope, our rise over run, looks like we're going up 1 and right 2. So 1/2 is going to be the slope of our tangent there, which means that is going to be the value of the derivative of f at 4. So that one's going to be a 1/2. And then, all right, I got a lot of stuff. Oh, I didn't want to move that. Let's see if I can move some of this green stuff out of the way. Okay, great. Let's do that. Let's do that. Let's get rid of those guys. Now we're interested in what happens when x is 7. So at 7, we're going right up here. Okay, and the tangent line that we would draw at that point, well, this is going to be interesting because kind of looks like we have a curve to that one right there, but it looks like this is maybe the vertex of the parabola if you wanted to look at it that way. More importantly, it's a point where the curve seems to change from increasing to decreasing. We would have a horizontal tangent line passing through that point right there, and the slope of that tangent would be 0. So f prime of 7 is going to end up being 0 as well. So those would be the answers right here. Now, I do just want to point out very quickly that if the question had been asked, what is the value of f prime of 8, let's say, this is a significantly harder problem than everything that we just did. At x equals 8, okay, I'd be looking at this point right over here, and I can see that at that point, my curve is nonlinear, all right? It definitely looks like it's decreasing, and if I had to guess, I would say my tangent line looks like it's maybe something like that. I can take a guess right here, guys, that, well, clearly, that tangent line is decreasing from left to right, so that our value right here would definitely have to be negative, but I can't really tell for certain what the slope of that line is. It looks a little bit steeper than -1, so I'd have to just take an eyeball guess right here that from here to here, I don't know, that looks like maybe it would be a slope of, I don't know, I'm just guessing maybe 3 down and 2 to the right, so maybe -3/2, but I cannot say that one with certainty. That would have to be an estimate right there. The only ones we can say with certainty are spots where your tangent line would be horizontal, which were here, here, and here, and then a spot right here where the function itself was linear. So in those cases, we can come up with an exact value for the derivative, but in anywhere that it wasn't one of those spots right there, the best we could do is take an educated guess. So those are our answers for the 4 parts of number 13.